Welcome to Truth Seekers. I'm Scott Walton, together with my brother Jody Bishop here in the chat or in the meeting. We are the Disciples of Yahweh. That's the name of our ministry and our fellowship. Tonight we have Don Deal as our speaker. He'll be talking about who's afraid of the Big Bang. We want to thank you all for coming out. Truth Seekers is where we have crucial conversations on topics of interest to Christians that glorify God and the Lord Jesus Christ. After the meeting is over, it will be available on our YouTube channel. You can find us by searching Disciples of Yahweh in Christ. And we're going to have this meeting for about an hour presentation. Then we're going to have time for Q&A afterward, about half an hour. We are a new ministry, and we do ask for your support. Please pray for us, subscribe to our YouTube channel, like any videos that you like, and share them with others who would be interested in the same topics. And now I want to throw it over to Jody to introduce our speaker. Jody.
My name's, like Scott said, Jody Bishop. We do have the ministry together, the Truth Seekers. Please subscribe, and help support the ministry by subscribing, sharing, and also liking if you really like it. I'm sure you'll like our guest today, Don Deals. Met him a few years ago, and Don is the director of classic apologetics for North Geisler International Ministries. He's got a master's degree in biblical theology studies from Luther Rice University and a Master of Arts in Christian Apologetics from Southern Evangelical Seminary. He is pursuing, now get this, he is pursuing an Islamic studies with Columbia International University. Don is a professor of scientific apologetics at Multiverse International University and a volunteer apologist with Scientific Apologetics Ministries with Reasons to Believe. He has taught or lectured in USA, South Africa, Philippines, Italy, Ukraine, Singapore, and has contributed even to a Harvest Handbook of Christian Apologetics and multiple articles for Encyclopedia. So let me welcome our guest, Don Deal. The floor is yours.
Thank you very much, Jody. And just to make sure the statement is clear, the school, I am pursuing a PhD from Columbia International University in Islamic Studies, but I am a professor of scientific apologetics at Veritas International University in California, one of two schools founded by the late, great Dr. Norman Geisler, the other one being Southern Evangelical Seminary. So I got a degree from one and teach at the other. And I've been studying and teaching science for many, many years, and happy to be here tonight. So what we're going to talk about tonight is we're going to say, you know, the Bible says the heavens declare the glory of the Lord. So we're going to say, what happens if you didn't have the Bible, no one had ever told you about Christ, and all you had was nature to look at? What would you know about God, and would you know about God from that? And so that's basically the story of science and the Big Bang. And so the talk is called Who's Afraid of the Big Bang? And let me share my screen with you, and then we'll, can everybody see that okay? Okay, I see thumbs up. That's Calvin and Hobbes, and there's Calvin saying, I've been reading about the beginning of the universe. They call it the Big Bang. He said, isn't it weird how scientists can imagine all the matter of the universe exploding out of a dot smaller than the head of a pin, but they can't come up with a more evocative name for it than the Big Bang? That's the whole problem with science. You got a bunch of empiricists trying to describe things of unimaginable wonder. And then Hobbes says, what would you call the creation of the universe? And Calvin says, the horrendous space kablooey. And Hobbes says, that is better. Calvin says, almost anything would be. And then Hobbes says, we should lobby to change that. And Calvin said, and I think tyrannosaur should be changed to monstrous killer death lizard. So we're going to talk about the Big Bang Theory that the scientists believe is accurate, and how they came up with it, what's the science behind it, and where the name came from. And then we're going to talk about how does that point to God. So we're not using the biblical text for this talk. We're using science and what people can learn about nature and about what's beyond nature simply by studying the universe. So the talk's called Who's Afraid of the Big Bang? And there's my special effects. That's the best I got. It's a little exploding universe. Here's the outline. We're going to talk about what's the currently accepted version among the majority of scientists. If you follow science closely, you know that there is no theory, there's no scientific theory that is accepted by every scientist in that field. So all you can say is that the majority accept this version. And you can't say within science that anything is proven. When somebody says science has proven, it means they don't understand how science works. Science it uses the inductive method, such as, let's say I'm studying swans and I see a white swan in my neighborhood. I say, okay, my theory is swans are white. I walk around, I see 50 swans and they're all white. Now I have higher confidence in my theory that all swans are white. I travel throughout the world and I see thousands and maybe even 1 million swans and they're all white. Now my confidence is very high in my theory. But if I go to Eastern Afghanistan and there's a brown swan there, then my theory's dead. So all you can say about science is that it gives you levels of confidence. It doesn't give you certainty. So this is the currently accepted version, but as with everything else, science is corrigible. That means able to change. And if you study the history of any part of science, you'll know that the accepted understandings have changed over time. And they cannot say that what we believe to be true now is certain, because we're human, we're limited in time and location, and so we can't know anything for certain. We can't know anything comprehensively. Only God has that ability. So what is the currently accepted version? What evidences do they have? That's going to be most of what we're talking about, is the scientific evidence. So if you don't like science, you're going to hear a lot tonight anyway. And then how can we use this information? And we'll have a discussion at the end of this. So what is the currently accepted version? It's called the hot inflationary lambda cold dark matter Big Bang theory. That's the whole thing, to which most people have that symbol at the bottom pop up in their head. What in the world? That's a really long title. And so what we're going to do is, in between each comma is a word or a couple of words, and we're going to explain what those words mean in this theory and how and why they believe that they describe the universe. So what evidences do they have for the hot inflationary lambda cold dark matter Big Bang theory? So the hot part, that's why I've highlighted the word hot there. Hot inflationary. Why do they call it hot? Hot versus cold. And by the way, the hot inflationary lambda cold dark matter Big Bang is known as the standard model of the Big Bang. And hot versus cold standard model. That gentleman there is Sir Fred Hoyle, the late physicist from England. He is the man who came up with the term Big Bang. He came up with it because he thought the idea was ridiculous. He thought that the idea sounded like theology, not science. He believed in an eternal universe. There's several lines of evidence why that couldn't be, but so anyway, I'll get to that in just a moment. But Fred Hoyle, he said, oh, so it all began in like a big bang. And so he used the term as a pejorative, as an insulting term for the Big Bang. And he proposed an alternative theory called the steady state theory. The steady state theory, we'll talk about that in just a moment, but even 150 years ago, they should have known that the universe was not infinite in size and infinite in time and age. Number one, stars burn out. as time goes by, they supernova. We know this. Everything runs down like a clock. Second law of thermodynamics. The universe couldn't be infinitely old. Number two, if there was an infinite number of infinite in size, there'd be an infinite number of stars. It's called the Olber's paradox. You should be able to look up into the sky, and everywhere you look should be as bright as the sun, because if there's an infinite number of stars shining their light for an infinite amount of time, then everywhere you look should be as bright as the sun. It isn't. That's only so because the universe can't be infinitely old. In a final way, they should have known that it wasn't infinitely old and infinite in size. It's called the gravitational paradox. And that's even under an older Newtonian gravitational system, the one conceived of by Isaac Newton. If you have an infinite number of stars and planets and things in the universe, and they are, you guys remember the inverse square law for gravity, if something's twice as far away, the pull of gravity is 1/4 the amount of pull. But if you have an infinite amount of stars, then the amount of gravity at every point in the universe should be infinite. It's not. So between the Olber's paradox of the stars, which they knew in the 1820s, or the gravitational paradox, either way, they should have known the universe couldn't be infinite in size and age. But let's just say the people who were getting into what became the hard sciences had a kind of they didn't like the idea, because, as I said, for Fred Hoyle and others, it sounded too much like the Bible and theology to say that the universe is infinitely old. I mean, if it isn't infinitely old, then where did it come from? So hot. Fred Hoyle proposed the steady state model. That is, he said, if the universe, within, this is getting really technical, but within quantum theory, it's said that within a certain volume of space that virtual particles pop into existence spontaneously, and they go out of existence spontaneously. They recombine and destroy each other. So these virtual particles, if you have enough of them, a small amount popping into existence over a certain amount of space, over time, you would create enough new elements that over time you could replenish the stars. And that's why all the stars wouldn't have burned out by now, is because the space is constantly creating new particles within that space. Well, he was proven wrong. By the 1960s, he proposed that in the 1950s. By the 1960s, he was proven wrong. Those two fellows, Penzias and Wilson, they discovered, and just to double back to Fred Hoyle, he was proven wrong by two lines of evidence: the cosmic microwave background, the heat residue from the beginning of the universe, and the abundance of hydrogen and helium in the universe. That is, his theory couldn't explain why we have the ratio of hydrogen to helium that we have, and his theory couldn't explain why there's heat in the universe. There should not be heat in empty space in a steady, eternally old universe. The heat should have long since dissipated, but it didn't. So between the heat and the hydrogen to helium ratio in the universe, he was proven wrong. These two guys, they were Bell Laboratories scientists, Arno Penzias and Robert Wilson. That is their microwave detector. And they pointed it away from the cities to try to test it and calibrate it, and they got a little heat residue. So they said, well, let's turn it up towards space. We'll point it at empty space away from stars and planets, and we should get a zero reading to calibrate our scale of detecting very low levels of heat, microwave levels of heat. So they pointed it at space, and they're still detecting heat. Well, at first they thought there was maybe some bird droppings were decomposing inside the receiver, and that was causing it. So they got their towels and cleaning materials out and cleaned their whole, you see how big it is. They spent some time cleaning it. When they finished cleaning it, they pointed at empty space, and then they pointed a different direction into what they saw as empty space. And every direction they pointed it, they kept picking up low levels of heat. Why would there be low levels of heat? Well, if the universe began in kind of a hot explosion, and let me clarify that, the Big Bang Theory doesn't say that there was space sitting out there and a bunch of matter exploded into it. That's not what the Big Bang Theory is. The Big Bang Theory is space came into existence, and as it expanded, it took energy, which then turned into matter with it. So the Big Bang Theory is not like a bomb going off in an empty stadium. It is as if the stadium grew up out of nothing, because everything in the universe came from nothing, according to the Big Bang Theory. There's different models, but they all agree that there was nothing and then there was something, and they can model it shortly thereafter it appeared. So that when Calvin said that it was a tiny dot, well, that's as far as they can model it. But the theory has the universe beginning from nothing, which is what the church has always held, called creatio ex nihilo, creation from nothing. God didn't use anything to create the universe. So these guys in the 1960s, they ended up getting a Nobel Prize for their discovery that the universe had a beginning. But when? Do they have a date? What can we learn about it? Well, next up, this is the map of the universe from a space probe called the Wilkinson Microwave Anisotropy Probe, the WMAP. This WMAP, if you look at that there, there's blue and red areas. The red areas are hotter and the blue areas are cooler, but it's uniform. You see differences here because they're highlighting it. They're actually uniform to 1 part in 10,000. So it's very, very much the same temperature everywhere in space, in every direction. Now that's kind of surprising, but this Wilkinson Microwave Anisotropy Probe, which went up around 20 years ago, I'm sorry, more than 20 years ago, it did several things. It nailed down the curvature of space. The question was, and I'll show some slides about this in a minute, is space curved in one direction or another? That is, do parallel lines intersect after a certain distance, or do they stay parallel forever? If space is flat, parallel lines continue parallel forever. And so what it showed is that 99.6% of the universe tested as flat. It's not that the other 0.4% is curved, it's simply that that's as far as their accuracy went, was 99.6%. They proved that it's a flat universe. And they determined that ordinary atoms, made up of electrons, protons, and neutrons, make up only 4.6% of the universe. That is, ordinary matter is less than 5% of the mass of the universe. And it completed a census of the universe and found that dark matter, which is matter that's not made of visible baryons, not made of visible, and we'll talk about that in a minute. But dark matter is 24% of the mass energy of the universe. So you get about 5% visible matter is what makes up the universe. 24% is dark matter, and the rest of the mass energy of the universe is dark energy. And that makes up 71.4% of the universe. What is dark energy? Well, dark matter, they're still trying to figure that one out. Dark energy, that's the stretching property of the universe. It says that the universe is being stretched out, which I might add, it says in the Old Testament that God stretches out the heavens like a tent, and it uses the verb form that indicates a continuous stretching. So the universe is expanding, and it's continuing expanding. And they measured the exact number for the cosmic microwave background. That is, that they measured the exact amount of heat left over from the creation event, which is 2.7 degrees Kelvin. That is on the Celsius scale, 2.7 degrees above absolute zero, which means the universe could not have begun an infinite amount of time ago. It began at a certain point in the past. There it is, this is where they're showing the model of how hydrogen and helium were made. We don't need to get into too much detail except to say this. People wonder, how do they know that the universe was 26% helium and 74% hydrogen? Well, you can do spectral analysis of stars and determine that. But how do they determine scientifically that that's what it should be? Well, how did that model predict that? Well, can you test the physics of that prediction? And the answer is yes. In order to combine and create those elements, you need 4 mega electron volts of energy. Well, I'm sorry, 26 mega electron volts of energy. Can we test that? Well, there's the Large Hadron Collider in CERN in Switzerland. It goes around and around a 17-mile circle, and it doesn't just reach mega electron volts of energy, it reaches tera electron volts. That is orders of magnitude more energy is used within that system in our scientific experiments than needed to test the theory that hydrogen and helium should be created at a certain ratio. You know, at this point, the steady state theory, the idea that the universe is really old and infinite in size, was dead. Well, there's a guy named Alan Guth. So that's the hot part. The hot part is there's still heat left over from the creation of the universe. What about the inflationary part? That's Alan Guth. He came up with the idea. There were certain mysteries they couldn't figure out on a standard if the universe expanded at a steady rate from the time it was created. There were certain problems. Number one, they couldn't figure out why the universe should be flat. We talked before about the universe is it's almost perfectly flat. If it expanded at a different rate, it would have been curved in one way and another rate curved in a different way. We are on the knife edge that if it expanded at a different rate, the universe would not have allowed physical life to exist. We're on that very knife edge where only the only rate of expansion that would allow life to exist. So it's as if you had a one shot in 100 million and you hit it on the first try. So they were trying to figure out there were certain problems. Number one, how do we get that flat geometry? How did it come out so perfectly? Number two, why is the temperature the exact same in every part of the universe? As the universe cooled and expanded, it's called adiabatic cooling. Same thing if you're at the top of a mountain, you notice the air is cooler than at the base of the mountain. That's because as the air spreads out, there's less energy in the particles and the molecules, and it feels colder. As you get higher in the air, it gets colder. Well, why is the universe so perfectly balanced in temperature? If you look at any two parts of the universe, they are within 1 part in 10,000 of exactly the same temperature. Why is that perfect? Because if the universe expanded at a uniform pace, there should have been more blobs of colder or hotter sections. So how could it be so perfect? It's as if different parts of the universe were in causal contact with each other. That is, one part and another, as if they shared heat with each other. So the problem is, in number 3, the standard model said that there should be what they call magnetic monopoles. That is, magnets with only a north or a south, if you can imagine that. Well, I interviewed a quantum physicist last year who used to work in looking for those. So they couldn't figure out, why aren't there magnetic monopoles? Why is the temperature the same everywhere? Why is the geometry flat? And this fellow, Alan Guth, he said, well, maybe in the early universe for a brief time, there was a period he called inflationary period, where the universe expanded at a hyper speed for a little while and then went back to a steady pace again. And that hyper spreading for a little while could explain all of these things. So the question is, do we have evidence for his theory? Well, by the way, here's the 3 different spaces. You see the triangle in the top one. If space is spherical, then the 3 sides of a triangle would be greater than 180 degrees, because as you can see, it's like the surface of the Earth. If you think of it that way, the lines of the meridian lines and such, the latitude and longitude lines, they hit each other at 90 degrees at the equator. But when you get to the North Pole, they all intersect together. Well, it's because there's a curvature to the surface of the Earth. Same thing, the middle one's flat space, which is what we basically see when we measure space. And the bottom one's called hyperbolic space. So that is, space would be more saddle shaped, where the three sides of the triangle are less than 180 degrees. So those are the different ways the universe could have been. The flat space, what we observe in the middle, is a very rare condition that requires very specific management of the universe. Well, there's that W map, which helped. Since then, they've sent up the Sloan. Well, let me get to this slide first. This is a that's the Bicep 2 probe, which is it's in Antarctica, where I know Jody wants to travel someday. He wants to be an Antarctic truck driver. I know that. And that one, they were looking for studying the polarity of the light in our universe to see if it was swirling in certain patterns that would indicate that the inflationary period actually happened. And so several years ago, I think about 5 or 6 years ago, they announced they had found the smoking gun. They had proven inflationary period. The only problem was they had not. The evidence they had was based upon comparing their results with these other results from previous tests. Well, they used not JPEGs, but they used lower quality files to compare it with, and it gave them the false reading. Turned out they were wrong about it. But the inflation has been demonstrated strongly in other areas, ongoing to this day, called Sloan Digital Sky Survey of Galaxies and Galaxy Clusters. Planck 2 and WMAP 3 maps of the cosmic microwave background all yield very strong results that indicate that the inflationary period did happen. So what's lambda? It's a Greek letter. Beyond that, what is it? Well, it's what Einstein called the cosmological constant. That is, it's what stretches space. It's that we call it dark energy. They call it lambda for short. So what physically causes the universe to stretch? Well, how can you tell the universe is stretching? If you use your eyeballs, how far can you judge distance? Maybe you can tell something with parallax between your two eyes is a certain distance. So the question is, how do you know that the universe is expanding at all? What evidence do they have? So how far are distant stars? Well, one way you can tell is through parallax. The second way is through Cepheid variables. We're going to talk about each of these. And the third is type 1a supernovae. That's parallax. If you use your eyes, you can judge distance to a certain amount. If you measure the angle to a star from two different telescopes on the surface of the Earth on each side of the Earth, then you get a little bit further out resolution than eyes, obviously, because you're 8,000 miles apart. Well, what if you took the measurement of the angle to the star from the same telescope at two different times of the year? Then in essence, your eyes, the distance between your eyes is the size of the size of the orbit of the Earth around the sun. So using parallax, just simple parallax, we can measure distances out to 65 light years. Well, 65 light years isn't far enough to really measure a stretching of the universe. It's too close. The stretching would be too small to measure. So you need something further. That is a GIF or a GIF, depending on how you say it, of a Cepheid variable. Those were discovered many years ago. And it works like this. Well, first off, you need a standard candle in order to measure light distance. If you see a star and you measure how much light energy you get from it, next question is, how bright is the star at its source and how far away it is? Well, you don't know that if it's outside of 65 light years. You don't know how far away the star is. So what can you use to measure distance? If you put a candle near your face, it looks really bright. If your friend carries that candle 2 blocks away, it looks very dim. So if you know for absolute certain what the brightness of a star is, then by measuring how bright it appears to us, its apparent brightness, then you can estimate to a very close number its actual distance. So the question is, how do you know how bright a star is at its source? Well, these Cepheid variables helped us to figure that out. That they build up a layer of gas over the star, which kind of dims the star, and then after a while, the heat energy inside the underneath that level of layer of gas builds up enough that it blows it off, and then you get a bright spot. Well, these periods can vary from a few seconds of light bright to dim to a couple of weeks of bright to dim. And what they discovered is that all the stars of this type all have the same chemical signature and are all the same size and work the same way. So now you have an absolute standard for measuring brightness. So now for these, it's not the brightness that makes a difference, it's the periodicity. That is how long between the bright and the dim phases. The longer the period between bright and dim, then the bigger the star is, and you know how bright it is. If it's very short, then the star is small, and then you know how bright that is. So based on how long it is between the bright and the dim cycles of these stars will tell you exactly how bright they are. And then you can measure not just the timing to know how bright they are, you can measure the brightness as it appears to us. And now you got a very good estimate for telling how far away that star is, that kind of specific star. By you measure its period to find out what its brightness is, and then you measure its brightness to us to find out how far away it is. Now you can measure distances accurately. Before I said 65 light years, now we're good to 20 million light years away, except that the astronomers like to talk about billions of years. So how do they get that measurement? Well, I'll run this one more than once. This is a type 1a supernova where a white dwarf is stealing material off of a red giant star. And when it reaches a certain level called the Chandrasekhar limit, here, we'll do it one more time just so you can see it again. When it reaches the Chandrasekhar limit, it blows up. Well, that's a very specific type of star with a very specific amount of matter being pulled into it. So it has a very specific brightness. And because it's a supernova, you can see it really far away. So that allows us to estimate distances accurately to 13 billion light years, which is almost as old as they think the universe is, the scientists do. Well, when you look at the most distant stars, you see that they're moving away from us faster than the more close stars. Well, the only thing that explains that, Edwin Hubble in the 1920s, the guy they named the Hubble Space Telescope after, he measured the redshift, that is hydrogen, which every star has hydrogen. Hydrogen puts out an emission line at a very specific frequency. If that star is moving towards us, then the light gets shifted towards the blue end of the spectrum. If it's moving away from us, it gets moved to the red end of the spectrum. Every star and every galaxy he looked at, Edwin Hubble looked at, was moving away from us in every direction. Well, the only thing that explains that is if the universe is expanding. Using the type 1a supernova 20 years ago, the scientists were able to now estimate how fast the universe is expanding. And they've discovered that it's expanding faster than ever now, that it's accelerating. What that means is that, like the Hindu theory of a cyclic universe where the universe expands, contracts, kind of a recreation model, the Hindus are popular with Hindus. Well, that's impossible. The universe is expanding too fast to ever recollapse. So lambda is the stretching property of the universe. What's cold dark matter? Is there proof for that kind of matter? We said before the W map determined that dark energy is about 75% of the mass density of the universe, dark matter about 21%, normal matter 4%. So we can actually see and directly detect 4% of the universe. It's not that the rest of it's too far away to see, it's that it exists in forms that we cannot detect directly. We can see the effects that it has, but we cannot actually detect it. So what can cold dark matter be? What are the possible candidates for cold dark matter? It could be an axion. That's a hypothetical subatomic particle. That it's hypothetical. They haven't actually seen it. Well, cold dark matter tells you, number one, cold means it does not interact with light waves. It's cold because over time, anything in the universe gets heated up from the light energy coming off of stars and stuff to the point where they will eventually heat up enough to give off light. Well, this matter doesn't. It's dark because it's never lit up. It does not interact with light in any direct way. They cannot see it. So the question is, after I look at some of these hypotheticals of what it could be, we'll talk about why they believe they have evidence for it. Well, it could be machos, which are called massive compact halo objects. Those are black holes, neutron stars, faint stars, large planets. Could be, if there's a lot more of those than we detect, then dark matter could be a macho. Could be a WIMP. Now, there's lots of different possibilities for dark matter. I chose these three because I like the names. We can't go through the whole list in 1 hour, but WIMP is weakly interacting massive particles. Weakly interacting means it doesn't interact with light. Massive means they have a mass. They have a gravitational effect. So why believe in cold dark matter? It will matter. Well, it explains the rotation of galaxy and Einstein lenses, and I'll show you those. This is a model of our our solar system. There's Mercury in the closest part, and of course, we're the third rock from the sun. And what you notice if you look at it is that all the planets closer to the sun move faster than those further away. Some of those on the outer parts are barely moving at all. That's because the inverse square law, the ones that are twice as far away get 1/4 the gravitational effect. So they're not being pulled as much. The closer you are, the more you get pulled. That follows Newtonian physics perfectly. But what if we look at other galaxies that are rotating? What we see is that the stars, you calculate how it should be based on those same physics, and that red line indicates that the further you get out from the center of the galaxy, the slower the stars should be moving. Just like our solar system works. So the stars nearest the middle should be going the fastest and rotating around. The ones further out should be moving more slowly. However, when you measure the actual speeds of the stars, the ones closer moving fast, and the ones further out are moving much faster than they should be. So what's causing this is as if the galaxies are gravitationally bound together, as if they're a solid disk instead of individual stars. Well, what could possibly have gravitational effect and yet not make enough light? Because those stars, not enough stars to explain how this is working. Something else is going on. This is a theoretical Einstein lens. This is Einstein came up with this idea. He said if you have a distant galaxy and you had something in between with a lot of mass to it, like a cluster galaxy, well, the light from the distant galaxy should be bent through space, that the space would be warped by the closer one, and that from Earth on the bottom right side of the picture there, those two orange lines, you should be able to see the same galaxy showing up on different sides of the intervening galaxy. You should be able to see something weird like that. That was his theory. This is a picture of an actual gravitational lensing. You can see some stretched out, distorted galaxies there that are the light's being bent and reflected around. Those galaxies aren't curve shaped. That's just how the light reaches us. Those are distant galaxies behind the ones closer to us. The problem is the light shouldn't be bending that much. There's not enough mass in those galaxies. When you measure the mass of the stars, it shouldn't be bending space that much. So once again, there's something else going on that is contributing a lot of mass to the bending of this and to the rotating of galaxies. There's something else going on there that's causing all this to happen. They can't see it. It's dark. It's not hot. It's not producing light. They don't know for sure what it is, so they call it cold dark matter. They have good reasons to believe it exists, but they cannot prove what it is right now. So Big Bang part, the Big Bang theory of cosmogony, and cosmogony means origin and growth of the universe, is the theory that the universe began from nothing and grew to the current size. It was the origin of space, time, matter, and energy. Now, I talked about redshift. As light waves move towards us, that's our eyes, and that light there in the square box is moving towards you on the right. It squashes the waves together to make the light look blue because it's closer together, and there's light waves moving away. And what they measure here, there's the wavelength for hydrogen there, and the bottom one is the laboratory reference for the hydrogen line. Stars we see, it's moved a little bit to the red end of the spectrum. Nearby galaxies, it's moved more to the spectrum, going from the bottom to the top. More distant galaxies, it's moved more, and very distant galaxies, the light has been shifted to the red end by a lot, meaning the further away from us what you're looking at is, the faster it's moving away from us. That means space itself is expanding. It's not simply stars and galaxies moving within space. Space is expanding. Think of this. You see those stars, green and red galaxies are that close apart, 1 million years. After another million years of that theory, well, now they're 2 million light years apart versus, you look at it again, see the green line. After a certain amount of time, the green to red galaxies have shifted by a little bit. The red to blue galaxies have shifted by a lot, because the further away the galaxy is, the faster it moves away. So what should we see? If this theory, if the scientists are right, then what we see is that the original stars, which would be heavy in hydrogen and helium only, and younger stars would have heavier metals in them, because those heavier metals would have been created through supernova and such, that the further away we look, the earlier in time to the universe we're looking at, because light takes a long time to reach here. So what we should see is, according to the theory, that we should see the Gerber baby at the farthest reaches of our visibility. Then you should see Beaver Cleaver a little bit closer to us, that is older stars. Then you should see Gilligan as you get closer to us, because those stars should be more heavy in metal and older. More mature. Get closer, you get Greg Brady. They're getting more mature as the stars get closer to us. A little closer, you get Ted Danson, and finally, you get Martin Sheen. So that's the theory. We should see the stars we observe, the farther away from us we observe them, the more immature they should be. That is, the more hydrogen and helium they should have. So what do we actually see when we look at the sky and measure the maturity of stars? We see those guys, Martin Sheen close. We see Ted Danson. Then we see Greg Brady, then Gilligan, then Beaver, then a Gerber baby. That is, we see what the theory predicted. The newer stars are more mature, and the most distant stars are more hydrogen helium mix, more young and more immature stars. So what's the result of this sort of thing? That's Arno Penzias. He's one of the two guys who discovered that the cosmic microwave background. He said the best data we have concerning the Big Bang are exactly what I would have predicted had I nothing to go on but the 5 books of Moses, the Psalms, and the Bible as a whole. So Arnold Penzias says, when we look at the universe, I see what I would have predicted if I only used the Bible. That is, there's a beginning to the universe. I'm sorry, that was Robert Griffiths. Let me go back because I messed that up. That's Robert Griffiths. He said, if we need an atheist for a debate, I go to the philosophy department. The physics department isn't much use. That is, the physicists realize there's theological implications to this. That's Arnold Penzias who said what I said. There's Jeffrey Burbridge. He complained in the 1960s when they discovered the universe had a beginning. He said all of his physicist friends have been too quick to run off, and he called it the first church of Christ of the Big Bang. That is, that the people were seeing God when they saw that the universe had a beginning. So this talk's called Who's Afraid of the Big Bang? Well, atheists are afraid of the Big Bang because it shows the universe began. They don't like that. Beginning implies there's a beginner. Not the stars didn't just begin, the space itself began, time began, matter, energy, space, and time all began. Atheists hate the Big Bang because it points them, without any religious books, it points them to a creator who is neither matter, energy, space, or time. That is, he's not made of matter and energy. He's not physical. He's spiritual, whatever the creator is. He doesn't exist in space. That is, he's once again, he's immaterial, and that he's a timeless being, an eternal being, and that it's personal because it chose to create. So just from the Big Bang, you get 40% of how we describe God just from looking at the Big Bang. So why do Christians avoid it? Well, it was too long ago for those who believe that the Bible teaches a more recent creation. The most common sense reading of the book of Genesis is day 1, morning and night, day 2, and such. And it doesn't say that it was a few thousand years ago, but it certainly looks that way. And some Christians avoid it because they misunderstand the event to be like a bomb going off, like an undirected explosion. In fact, it was so incredibly fine-tuned, the Big Bang and the universe growth and expansion is so perfectly fine-tuned that it's as if all the parameters of the universe have to be exactly where they are, the balance between the strong and weak nuclear forces. All these forces have to be perfectly balanced to allow us to exist. It's as if you walked into a control room and there were 2,000 dials on the wall in front of you, and each dial had 1,000,000 different settings, but every dial just happened to be at the only combination of settings that allows us to exist. It's called the anthropic principle. If you want to figure out what's going on in the universe, ask yourself, if I was designing a universe for people, what would I do? That's how scientists approach determining what happened in the universe. Look and pretend you're designing a universe for us, and you'll find what you're looking for. And some Christians don't like it because they think it implies evidence for the evolution of life. I can tell you, it doesn't matter if the universe is old or young. The evidence for evolution is really bad. The evidence for the origin of life is really bad, whether the universe is an old universe or a young universe. So how do we as Christians use this information? Well, here's the logic. Everything that begins to exist has a cause. This is universal experience. There are no uncaused events in the universe. The universe began to exist. Therefore, anybody want to guess the next part? The universe has a cause. What's that cause like? Non-spatial, you could say spiritual, because no space before the universe. Non-temporal, eternal. Non-material, spiritual. Personal, because he created the universe. And there was no, if it was a law-like force like gravity, it would be happening all the time. But the creation of the universe just happened once. All right, let me stop the sharing. And unfortunately, you're now back and looking at me. So do we have any questions now that I've completely thrown all this science? There's 40 years of science study just tossed at you in 49 minutes. If your brain is still working, I'll be happy to answer any questions about this or anything related. Yes, Jody.
What is the strongest evidence from the Bible that you would have to believe what you believe about the Big Bang? Where in the scriptures would you believe the strongest evidence is?
Number one, I didn't say I believe that the Bible teaches the Big Bang. Number two, if I had to pick something, I guess it would be where it talks about the stretching out of the heavens that is continually being stretched. As far as the Big Bang goes, my
Okay.
children, when they were small, got into a debate, and my older son was an old Earth creationist, and he was debating my younger son, who was a young Earth creationist. And I was driving down the road, and I didn't know what they were getting heated about, but I heard my, at the time, 6-year-old say to his 9-year-old brother, "I've read the Bible, William. It doesn't say Big Bang anywhere in there." So in order to fit the Big Bang Theory into a Bible chronology, you would have to take the Hebrew word yom, day, to mean a finite extended period of time as opposed to a 24-hour period. That I guess you could say, and created the heavens and the earth. And when God said, "Let there be light," and such, actually there was a period, according to the Big Bang Theory, where light emerged. That the early universe was so compact with subatomic particles and energy, there was no room for light to exist as something separate. So about 300,000 years after the creation event, what that cosmic microwave background, that heat we see, is the light left over from, you could say, a scientist who believes in the Bible could say, if he believes in the Big Bang and the Bible, he could say that is when "let there be light" came. And so one scientist who saw that WMAP image of the cosmic microwave background, that heat, hot and cold sections, he said it's like looking at the face of God. He said, "I'm not a Christian, but this is like looking at the face of God," because he saw the point where light was separated from darkness. So when God said, "Let there be light," you could say that way. Basically, you would have to take most of Genesis and say that there's some metaphorical language if you want to combine the Big Bang with the biblical chronology. You'd have to say that the Hebrew word yom means finite period of time, but long. You know, the day age theory type idea, that the Hebrew word yom can also mean an age. And we use the word day that way sometimes, and even in English. If I say in my great grandfather's day, they used to bring ride horses to church, I don't mean my grandfather only lived one day. He certainly lived longer than a day, because he had to live long enough to grow up and produce my grandfather and such. So we use the words that way sometimes. So I would say that they would say either we're not understanding the ancient Hebrew terminology well enough, or they would say it's a metaphorical usage in there. That's how you would work the chronology in. Oh, and I'm sorry. And finally, they would say, don't just use Genesis, but use the entire Bible to see what it talks about, where sometimes they seem to be strong implications of great periods of time, but without, once again, specifying how long that is. And if you're a young Earth creationist, you say that the Big Bang sounds nice. Glad scientists can see that there's a God, but it's not the Bible. You say that it was 6 days, maybe six. It happened over 6 days, 6 to 10,000 years ago, and that the problems with distant starlight and such will be solved when we know more about how physics works. I mean, think about it. They know 4% of the mass of the universe. They know what it is. 96% of the mass of the universe are called dark matter and dark energy. Dark meaning we don't know. So it's not as if the physicists, the cosmologists and stuff have a drop dead argument to say we know certainly what's going on, when you can only identify 4% of what's going on. They can measure and tell that something's going on, but they don't know what's going on. And the reason is because it's, as you look at distant starlight, it's either really old or something else has gone on to change the speed of light, which we don't currently know how that could happen.
Jody,
Okay, anybody else?
okay. Yeah, I wanted to make a comment, Don. That's something I was thinking of when you were talking about the 4% of matter that they can observe, and the energy that is observed and not observed. You're kind of shooting yourself in the foot when you come up with a theory that says I've observed very little of the data, and yet I know 100% of the conclusions.
Right. That's why I say, when they say that when somebody says science proves anything, you got to roll your eyes, because science doesn't prove things. They give evidence to support theories, but that's it. And yeah, the idea, I get a laugh out of this. I just ask them, oh, so they solved the 3-body problem? The 3-body problem's like this. using gravitational mechanics, you can estimate like the Earth and Moon combination, where the moon's going to be in 100 years, 1,000 years, if you only had two bodies. Once you add in a third body, a third planet or moon, once you add in a third, the math gets too complicated and we can't calculate it. Only 3 planets makes the math too complicated to follow. So the idea that science has all the answers is just not there. Science knows an awful lot and they work really hard and they're really smart people, but they don't have all the answers. And it's interesting to me, as I've interviewed scientists and spoken to many scientists over the years, how many think, well, we don't know everything in my field. I mean, we're still struggling, but those other fields, they really know what's going on. And then you go talk to the people in those other fields and they say, well, we're not really sure what's going on. I'll give you a perfect example. At a Origin of Life conference, an atheist scientist said at the conference, can anyone tell me one thing he knows for certain is true about the theory of evolution? And nobody answered.
That's great. That reminds me of the John Lennox quote. I've heard him say this a few times. Outside of his area of expertise, the PhD scientist is as dumb as the next fellow.
Absolutely. There's a Christian who's worked with Stephen Hawking when he was alive, the late great British physicist, who I got to say I excitedly ran into one night on the street in Cambridge, England. You can't talk to a guy who uses a voice box, but I was still excited because I read a couple of his books and such. For me, it was a superstar movie. Like the people who read the tabloids, if they saw a celebrity, they would go get excited. For me, I was excited because I met my celebrity. But anyway, one of his friends, who's a physicist and a Christian, he said, I've known Stephen Hawking for more than 20 years. I can tell you that he's read next to no philosophy and he has read zero theology. When he speaks about anything other than physics, he's an amateur. And yet he wrote, his last book was called The Grand Design About the Universe, in which he says the universe is not designed, it's just an accident, and that the universe created itself. And I find that interesting because logically, in order for the universe to create itself, all it had to do was exist before it existed.
Right.
Existing before you exist, that, I mean, my children, when they were small, they went, what? They realized what nonsense that was. But there's a lot of people out there who think that's good science, I guess. I don't know. I know I asked a question on a British website after he talked about Stephen Hawking said, if such a thing as gravity exists, then the universe can and will create itself. And I said, I don't understand what gravity is if there's no space for it in which it can exist. I don't understand that. And a guy said, well, any grade school science teacher could teach you that. And if I'd have been a smart aleck, I would have written back and said, are you not a grade school science teacher? Because you didn't explain it to me. I'm still wondering. I wasn't saying this proves him wrong. I'm saying I don't even know what he's talking about when he talks about gravity and not talking about space where it can exist. If there's no space, where does gravity exist? And there was no answer because he's Stephen Hawking. I'll tell you how bad of a philosopher he is. In that last book, The Grand Design, he spent the first 3 chapters explaining how philosophy is dead and that science is the only way to know anything. Then he spent the next 2 chapters explaining what his philosophy is. And I said, you just spent 3 chapters saying philosophy's dead, and now you're telling me what your philosophy is. Is it dead or is it not dead? I mean, am I not supposed to follow? Am I supposed to forget the previous chapter when I get to the next chapter? It was not a very good book. Several physicists criticized it severely. The other book that was an attempt to explain the creation of the universe, besides his book, which was a big failure, was a book called A Universe from Nothing by now I forget his name, Arizona State University.
Lawrence Krauss.
Lawrence Krauss. Yeah, in that one, he says the universe is basically an illusion, that it's a balance between expansion and gravity and all that, and that basically he's saying that, like, when you toss a baseball up in the air, it reaches a certain point where it's neither moving up nor down, and that it's neutral there. That's what our universe is. And I thought, well, if our universe is that, then it still exists because you just told me of baseball, and now you're telling me doesn't really exist. And it just, and even physicists have made fun of his book. It's not well received in the science community. It's just well received. Both those books are very well received in the atheist community, but not in the science community that knows what they're talking about.
All right, I have a science question based on something you said in your presentation and a little bit of logic thrown in there. You
Okay.
gave a definition of the Big Bang, or I don't know if you call it a definition or a description, that the universe began from nothing and grew to its current size. And I'm assuming that you're saying this is what the scientists, the secular scientists would say, because that actually sounds somewhat incoherent to me. You start out with nothing, nothing grows to double its size, double nothing is nothing,
Right.
and then it quadruples, it's still nothing. So
Right.
obviously that's not a proper definition, but I did want to ask, what do the secular scientists say? How do you move from nothing to something? What explanations do they have?
They don't. They are trying to. Number one, they say that our universe is part of a multiverse, or the Big Bang Theory itself, the mathematics of it break down at what's called Planck time. Max Planck was a scientist who said that there's certain regimes where they're immeasurable in size and time. So it's like 1 times 10 to the minus 39 or something like that. So it's like 0.000000001 seconds that you can't do any math and any modeling. So the universe begins after it was created. The model of the Big Bang begins after the creation event. But the theory itself says that there was nothing and then there was something, and that something grew.
That's not very satisfying.
Well, God created the universe. It was nothing out of nothing. That's what the theologians have been saying for 2,000 years, that God created it not out of pre-existing matter, which is by the way, a Mormon position, but that God created it out of nothing. Not ex materia, but ex nihilo, from nothing. And that's pretty much what the theory models. The idea is the universe began from nothing and then existed. Now, when I mentioned the multiverse theory, that's the current favorite child of the atheist community, and the reason is their hypothesis is that, and there's different multiverse theories for those who aren't familiar with it. There's the one that says our universe is infinitely large, but we can only see a finite part of it. There's another one that says that our universe, there's separate universes that are not connected to each other. And under the prevailing version that's most popular, they would say that out of a multiverse, out of a quantum foam, some different buzzwords they use, that these universes spring into existence. The only problem is that there's not only no test that has demonstrated that to be the case, there's no test that could demonstrate that to be the case. We can't go beyond Planck time going backwards, so we can't test what happened before that point. So and number two, the other problem with the multiverse hypothesis is that it's based upon the idea of string theory. Now, string theory is a theory within quantum mechanics, the science of the very small subatomic particles and such, that says instead of thinking of subatomic particles as like tiny billiard balls, point particles, you think of them as tiny vibrating strings. And in some ways that makes the math work so that you could have general relativity and quantum theory work. Most people aren't aware, general relativity, Einstein came out with that in 1915. It's a theory of how gravity affects things, bending of space, light, all that sort of stuff. We know that's accurate to 19 decimal places. As I said, we don't know anything for certain in science, but that one's been demonstrated accurate 99.999999999 19 decimal places. Very, very well tested. If Einstein was, our GPS system is based upon that theory. We have very accurate GPS because they take into account the fact that when you're nearer to the Earth, the gravitational pull is greater than when you're further away. and that affects the travel time for the signals to and from the satellites. If you don't take into account the general theory of relativity, you get very bad GPS. If you take it into account, you get accurate GPS. So we have very good experimental evidence to suggest that the general theory of relativity, how space and time is warped by mass, we have very good experimental evidence to indicate that's correct. Now, quantum theory, they've made atomic bombs. You know, remember Einstein's special theory of relativity, 1904, E equals mc squared, all that. That's how you come up with atomic bombs and stuff. That's been tested multiple times and proven to be very accurate. That's why we have cell phones and computer technology, the microscopically small computer parts, is because we know how quantum theory works in general. There's a lot of research to be done still, but they have a very good understanding, and that's why our electronics work. Both have been proven to be very accurate. The quantum theory, very small. General relativity, planets, stars, very big stuff. What happens if you take general relativity and start applying it to smaller and smaller cases? And you take quantum theory and apply it to bigger and bigger cases, and you reach an area where the two theories can overlap, and you can see, do they both give the same answer? And the answer is they don't. There is a conflict between general relativity, the science of the very big, and quantum theory, the science of the very small. They don't work together. Because of that, they've been trying to find a way to bring the two together in string theory, the idea that the subatomic particles are tiny vibrating strings, orders of magnitude smaller than anything we could measure, that those that helps mathematically bring the two theories together. The problem is if the ultimate breakdown of matter is strings, we'll never know. You would need a nuclear accelerator. This is one scientist told me. You need a nuclear accelerator the size of our solar system to get up enough energy to test it. And he said that Congress was not funding nuclear accelerators the size of our solar system. Yeah, kind of hard to believe, but no, yeah, it would be physically impossible it's physically impossible to test string theory. It's a mathematical theory. Well, there's different versions of string theory, just as there's different multiverse theories. The only evidence for multiverse comes from string theory, which is untestable. So you got a hypothesis leading to another hypothesis. I asked the astronomer Hugh Ross about that and the multiverse, and he said it was hypothesis squared. It's just like conjecture so far out there that there's no conceivable way to test these theories. So that's the atheist's best explanation. The multiverse is for where the universe came from since it began, is hypotheses are conjecture squared. It's just they have no evidence. All they have is the hope that someday they'll find evidence that God didn't do it.
All right.
Not a very strong argument.
Thank you for answering my question. And now I'd like to see if anyone else has a question.
I realize that for people who don't have a strong science background, that this was really a fire hose of information in a short time. So I suspect that if when this is posted on YouTube, that over time I'm going to get nitpicked because I'm sure somewhere I said some little thing wrong or I misstated something, and I'm sure the atheists are going to tear me apart about something that's inconsequential to the whole idea that the evidence points to a creator of the universe, regardless of whether it's an old or young universe. If it's a young universe, then the Bible clearly says there's a creator. If the science part is right, then that points to a creator. So for us, it's heads we win, tails we win. Either way, we win, old or young universe. There's a creator.
Amen.
And I like that.
Sure.
Yeah, absolutely, Dr. Lewis.
You know what is so interesting, the information you shared. I did love science when I was younger.
Mm-hmm.
My thing is that they can't explain how the waters, like God explains how the waters came together and the matter and the earth, but for some reason they have no scientific explanation for the waters and the earth forming in it of itself.
Yeah, the standard model of how the Earth formed would tell you that asteroids brought water to the Earth.
They must have had some big buckets. Yeah.
They had some big buckets because when they try to make a theory of how the Earth itself formed, they say
Right.
that the solar system's disk formed about 4.6, or the Earth formed about 4.6 billion years ago, and it was initially very hot and molten. And then at about 4 billion years ago, as it was starting to solidify, there was so much debris bouncing around in the universe. You know how the moon's covered with craters. Well, the Earth has 6 times the gravity of the moon, and more than or it's 6 times larger, 8 times the gravity of the moon. The Earth would have gotten pounded much more than the moon ever did. So they call it the late Hadean bombardment, meaning Hades as in hell. So the Earth would have been pummeled to a couple of 100 meters deep, or excuse me, a couple of kilometers deep, molten surface. Then it cooled and water came. And then if you look in the fossil record, as soon as you can find some solid rock, you find evidence of life. So physical life is there at the beginning. So they have no idea how life could form on the Earth. They make it sound in the news stories and documentaries like they were this close. No, they're not. They're not even. I'll give you one example. Like the molecules that form amino acids and proteins in bodies, they come in 2 different forms, left and right-handed, like our hands. They're mirror images, but they're not exactly the same because you can't. Well, their molecules are the same way, these biological molecules. When you form them in nature, that they say made up the first life, when you form them in nature, they always make up what they call a racemic mixture. That is 50% left-handed, 50% right-handed molecules. That's the only way it can be made. The most they've ever in experiments been able to get to is about 80% one way, 20% the other way. The problem is life only uses left-handed molecules. 100% left-handed molecules. They have no idea how that could have happened. How could you get thousands and thousands and thousands, hundreds of thousands of only left-handed molecules in one place for that first life to suddenly pop into existence? That's just one of a myriad problems with the origin of life scenarios on Earth. So to say that there's problems in sciences, yeah, any scientist who's honest will tell you there is. They'll try to make it sound like they're very sure, and as I said, like with Einstein's general theory, they're pretty sure. The only problem is, what consequence does that have on our life? Whether light bends, how much light bends and all that. That makes no consequence. The theory of evolution has a big consequence, because if life simply appeared accidentally on Earth through what they abiogenesis, life from nothingness, non-life. Chemical evolution, they call it, with the first molecule of the first cell formed. If it comes from nothing and then it went through biological evolution, increasing complexity and such, and you get more and more complex creatures, and finally the apes and then us, where does morality come from? Is morality something programmed into us by evolution? In which case, and why are they trying to change my mind about abortion? Because if my morality is programmed into me by DNA, I can't change my DNA. So why are you trying to change my mind? Number two, the only other choice they say is that it comes from sociological forces within societies. Well, if that's the case, then we have our morality and the Nazis had their morality, and there's no way to say which one's right or wrong. Well, I think everybody on Earth believes that the Nazis were wrong to kill 6 million Jews and hundreds of thousands of gypsies and other people they killed. Everyone knows that's wrong, except from an atheist perspective, there's no way to explain why it's wrong. It's only if there's a moral law, which comes from a moral lawgiver, are things right and wrong. And so that's what we're seeing in our society in America right now, is the conflict coming from younger people raised on the idea that our life is meaningless. And then they're trying to figure out meaning for themselves. Well, they have 10,000 different ideas of what meaning is. And so they're fighting about all these ideas, and there's so much strife and struggle on our young people and confusion, because they're being told that everything is meaningless, but go on and be a good person. Well,
Yeah, what boggled me was also that they really can. I asked the guy, he went to some college. I said, can you explain to me how did we obtain knowledge? How did
yeah,
knowledge get into human beings?
right.
So just like I was reading Job, the Bible explains that he's having a conversation, he's getting
Yeah,
questions from
sure.
someone who is out of the universe,
Yeah,
of Pallades and Arcturus and
yeah.
Mizrath.
Oh, yeah.
How did Job attain this such knowledge?
Right. Oh,
And there's no life on other four. I mean, they can't tell us scientifically
right.
um, whether life is on another planet. We don't have that technology. That knowledge is not attained yet. So
I'll tell you something wonderful. The Apostle Paul wrote that before time began, God was planning.
mhm.
Before time began was a theological idea. What does that mean, before time began? Well,
Mm,
the Big Bang Theory says that the beginning of the universe was the beginning of matter, energy, space, and time. Time
mm,
began. That's a physical property of the universe. Time is, according to Einstein, space and time. They call it space time. Space
mhm.
time is a physical property of the universe. Time began with the universe. 2,000 years ago, the Apostle Paul was saying the same thing that scientists are discovering now, that time began. Apostle Paul said before time began, now they're proving that time began.
And
Something
my
that,
last thing is
yeah.
the when they found the bones of the dinosaurs,
Mhm.
they're saying billions of years, but the tissue matter, the tissue
Right,
in the bone marrow, it
right,
doesn't add up. I mean, like,
right.
it doesn't take a brain scientist. Tissue ain't going to last millions of years.
Yeah, I know you're referring specifically to the soft tissue they've been
Soft,
discovering.
soft tissue, yes.
Yeah, yeah, exactly. That's a major hurdle to overcome, and there, uh, some would call it circular reasoning, where you say it's old. It must be old, but it is soft, which can't be old. So there must be something happening that we don't understand that makes it old yet soft. And so we'll see.
The only thing we could go on is God took the simple things to
Yeah.
confound the
Oh yeah.
wise.
Yeah, I tell you, there's I can't remember the writer's name in the 20th century, but he ended his sentence with, "We have educated ourselves into imbecility."
Oh my goodness.
Yeah, I forget the whole phrase, but that ended with that, and that's always stuck with me, because I meet some people who are really well educated who say the most, like Stephen Hawking, the universe would create itself. Yeah, a brilliant physicist who would say it's something that means the universe existed before it existed, and that's how it created itself. Well, you can't exist before you exist. So it's just pure nonsense. But because he's got a PhD after his name, people go, wow. Yeah, it's sad.
What boggles me is these scientists who don't like God, they're so deep
Yeah.
into their atheism, but
Yeah.
yet when they die, they go into a church and
Oh,
they
yeah.
have funerals.
Oh, yeah. Jean-Paul Sartre was a French existentialist philosopher. Existentialism is a turning of everything the Bible says on its head. The Bible says God conceived and created. That means that our essence came first. The idea of us and what we are came first in God's mind. Then we had existence. So it's essence first, then existence. Jean-Paul Sartre, the French existentialist philosopher, reversed that. He said, your existence comes first, then you choose your essence. And that's where we get a lot of like gender confusion and stuff. People are being raised on this philosophy, believe that they exist first and then they choose their own essence. And because you choose your own essence, and a preborn baby doesn't get to choose its own essence, it's not a thing yet, according to this philosophy. So this philosophy has led to so much death and destruction in our society, and yet it's the fallback philosophy of of the atheist world. And so many in our youth and our church are influenced by this philosophy without realizing it, through media, through TV shows, music. They're really influenced on the idea that you create who you are, not that God created who you are. And so our society, everything's being turned on its head from what it's always been. And we're seeing the destructive effects. I mean, the people marching and trying to take over the Capitol, those were conservatives who were supposed to be the most law-abiding. The people who, I mean, the riots in the cities in the West, it just everything, everybody everywhere is going crazy. And it's all because you turn it up. When you take God from the top and put him at the bottom, everything's going to go wrong.
You would think, that you would think that when they found out the DNA pattern, the DNA code would have really showed them this is God's print. You cannot just pick codes and design, God designed it.
I have another talk I give. I teach scientific apologetics at Veritas to the Doctor of Ministry students. I have another talk I give. It's called Does DNA Equal God? And so that's another talk. I've given that talk at the National Conference on Christian Apologetics. That one, when I gave it in South Africa a couple of years ago, there was a medical student who was concentrating, and about halfway through went, as she realized what I was getting at, that information is not a molecule. DNA is an information bearing molecule, but the information is not a molecule. You can put information on a piece of paper. I can speak it to you. I can sign language it to you. You can put it on a screen. Information can be carried in different floppy disk, you name it, or that's for the old folks, the floppy disk. There's different ways to transmit information, but the information itself is not physical. What carries it's physical. Same thing in DNA. The molecules are physical, but the information they carry is not physical. Well, where does information come from? Because the simplest life, the amount of information is volumes and volumes and volumes of a book that has to be exactly in the right order to program how that life is going to work. Well, where does that information come from if not a mind? And so
now you've done it, Don. You've gotten yourself invited back to come and do that talk.
I'm sorry, I couldn't hear you.
Another science question I wanted to ask. You talked about the way that they can measure the distance to things by parallax, Cepheid variable stars, etc. Have they measured by one of these methods the expansion of the universe? So for example, measure a bunch of objects, see where they are, wait 10 years, measure the distance to those same objects, and we see they're ever so slightly further away. Is that something that can be measured?
They've measured the redshift of the objects. So like I said, the hydrogen line of stars is at a very specific frequency. And if it's moving towards you, it shifts towards the blue end. And because they get compacted, the light waves get compacted if it's coming towards you. If it's moving away, the light waves get stretched out, which means it shifts towards the red end. What they discover is that the stuff nearer to us is moving at a certain speed away from us. Everything is. If you get further away, it's moving faster away. If you get further away yet, it's moving even faster away. They can measure through the redshifts and the various methods we talked about earlier, how fast they're moving or how far they are. And so you can tell from how far and how much redshift and how fast they're moving away from us. And the further away in every direction you look, the faster they are moving away from us. And the only thing that can explain that is the universe is expanding.
Well, the way I understand it, so what you're saying, they haven't measured the expansion by checking distances over time.
It's possible they may have. I don't know. I've not researched that specific question.
Okay, but when it comes to the redshift of spectral absorption lines in the light coming from distant things, as I understand it, there are other mechanisms that could account for that redshift.
Well, sure. There's all kinds of theories of how it could happen. And by the way, you said absorption line is emission lines in the case of stars.
Sorry.
Other things absorb the light and such. These emit the light, so there's emission lines. There's a little bit of difference. There's all sorts of theories and hypotheses on how this could happen, and that gets back to what I said earlier about nothing is proven in science. Absolutely. And I'd like to make one more point about science. the remoteness issue. The closer something is to us in size, time, and proximity, the more certain we can be about our study of it. So if you look further back in time, then we're less certain. If you look at smaller or larger than us by a lot, we're less certain. And if you look by proximity further away from us, we're less certain. So we have less certainty about galaxies further away from us than our own galaxy. We have less certainty about planets further away from us than our own. So the more proximate something is that you study, the more certainty you have in your results. Well, the theory of evolution and the Big Bang Theory are theories about the past in the greatly distant past. And so we have less certainty about those. Certainly any theory in science could be overturned in a single day. And I'd like to say, secondly, we've talked a little bit about the theory of evolution. In science in general, there's two different kinds of theories. There's realist and anti-realist theories. A realist theory says that what we're describing is what's really happening. An anti-realist theory says, I'm describing this and modeling this and making predictions based upon it, but I'm not saying this is necessarily really happening. And so once again, the more remote what you're studying is from us, the more the philosophy shifts into the anti-realist interpretation. So the theory of evolution is a story that explains things. It doesn't have to be literally true. So if you're trying to convince a hardcore evolutionist that there's problems with the theory of evolution, you're trying to tell him that his story has issues, and he's thinking, well, yeah, on page 23 there's a problem, but the book is good. And so you're trying to give a realist explanation for things to a person who has a anti-realist understanding of how it works. And so we're talking past each other when we talk to the atheists who believe in the theory of evolution. It's one of those problems that I don't see being solved in the near future, because it requires knowledge of the philosophy of science and science at the same time. And there's not a lot of people that have bothered to study both.
Wow, thank you. Thank you for the correction. I did not know that that was emission lines. I thought it was absorption lines, because people really rarely ever say that they are lines at all, whether emission or not. They just say redshift, as if there's Doppler expansion. And I recently had discovered that there are some scientists, even secular scientists, who are saying the expansion has not been proven. They're not necessarily denying it. They're just saying it hasn't been demonstrated. And I've seen this quote from Hubble himself near the end of his life. In a paper he wrote, the possibility that redshift may be due to some other cause connected with the long time or distance involved in the passage of the light from the nebula to the observer should not be prematurely neglected. And when he said some other cause, he meant other than galaxy recession.
Right.
I thought that was very interesting. Now that brings up another question too, unless you want to comment on just that part.
Well, I was going to say that the theory of the Big Bang Theory, all the different parts, I said the hot inflationary lambda, cold dark matter, Big Bang Theory, he died before a lot of that came out. And so they've modified the theory since he made those comments. And the evidence for the expansion of the universe is stronger now than it was when he did. All he could measure was the redshift of galaxies that he could observe from his time in 1920s. Certainly there's always a possibility there's something else going on. I mean, we don't know everything, but the evidence for the expansion of the universe is been, every time they've tested it, it's come out in one direction only, that the universe is expanding. It's never failed to test, which only makes it a stronger theory, kind of like my swans theory. Once you've looked at 1,000 swans and they're all white, you're really, really confident they're all white. Well, the expansion universe is that way. They've seen 1 million white swans now, but it does not mean that over the next hill is not going to be a black or a brown swan. So once again, science, by using, in logic, the three big forms of logic are deductive, inductive, and abductive. Deductive, such as all men are mortal, Scott is a man, therefore Scott is mortal. Oh. If your premises are true and your form is valid, this conclusion is sound, meaning it's proven, and the only way you can deny the conclusion is to admit that you're irrational. Deductive logic is certainty. Inductive, the Swan's example, the more examples, the stronger. That's the levels of confidence. The final version is abductive. Say you walk into a doctor's office and there's a jar of jelly beans on the table, and next to that jar are 4 jelly beans. Where did the jelly beans come from? The jar? Did you do a deductive analysis of that? Did you do a study of jelly beans falling out of jars over your life and determine that they always fall out of jars? No, it's called abductive reasoning, or reasoning to the best explanation. That is, it makes the most sense that those jelly beans on the table came out of that jar. That's just common sense. Well, most of our arguments that we use in science to talk about God tend to be in the abductive direction. That is, they make sense of the evidence, but for someone who doesn't already believe in God, they're not as persuasive as a deductive or inductive argument. So it makes perfect good sense of all the evidence to say God exists. That is the best explanation. But it's not the only possible explanation, because the atheist can always say there could be something else we don't know about. And so that's why, if they're determined to hold on to their atheism, then our arguments aren't going to necessarily change their mind. Sometimes they do. I'll give you a perfect example. Sir Anthony Flew was considered the world's most influential atheist philosopher. The last book he wrote before he died was called There Is No God, because he was an atheist, but then God, the word no was crossed out. So it said there is a God. That is, in his 80s, he came to believe that God existed as a lifetime atheist. And he said the reason was primarily because of our investigations into DNA. DNA convincing there had to be a mind behind it all. And so atheists can be convinced, but let's be realistic. It's more about their hearts than their heads. And so we can provide arguments because God tells us to, 1 Peter 3:15 and other places, but our arguments aren't going to change anybody. It takes the movement of the Holy Spirit to change them. And so we do our job because we're commanded to, and I love doing my job. But at the same time, if they don't convert or they don't get it, I don't fret about it, because God's in charge of conversion, not me. I just got to keep providing what's available from me.
Well, and we have loved having you, Don. We've reached the end of our ordinary time, though we can hang out and chat if anyone wants to.
Right.
And we'd love to have you back, as already said. And it's been great. Thank you so much for coming out and speaking to us.
Well, thank you, Scott and Jody, for having me. And I just want to say, Jody, if I come back again, I want double the salary next time.
Like I said, twice nothing is nothing.
Well, thank you guys for having me.
What do we know? How much do we actually know about these black holes? I mean, it seems like I guess we're learning more, but we still don't really know nothing.
Well, we've imaged them at this point. That is, that they've now put together little bits of data from millions of telescope observations, and they've actually made an image of a black hole now. It sounds funny, but as the objects, stars, matter, debris fall into the black hole, it accelerates and drops in. As it accelerates, it glows, and the black hole itself is rotating, so that there's a point where the light is coming towards us and a point where the light's going away as things fall in. And where it's coming towards us, it makes a brighter glow, so you see like a kind of an slight orange globe with a brighter side to it. And they have actually made an image of a black hole. They've got evidence with stars orbiting something at the center of galaxies, and these stars are moving at millions of miles an hour. They're being sucked like crazy from something that's invisible at the center of the galaxy. They're orbiting something that you can't see. And so the evidence for black holes is really strong, but they're not near us. And so once again, directly detecting them would be really, really hard. But there's the theories and the observations are matching, so they feel confident that they've demonstrated that black holes do exist.
I wanted to ask about the when the archaeologists, they do the timing on the rocks, they figure out how old the rocks is. And in creation, in the beginning, the first chapter, it says the earth was without form and void.
Yes.
Now, I'm trying to get the understanding of what was there. Was the earth just as that matter sitting in darkness, and then we have a time, the time life actually came about on the earth. So how far back do you think that they're going to calculate that time? Explain that to me a little bit.
Well, when you talk about when you say archaeologists, that's generally carbon-14 dating. That
Yeah.
only works with things that are living.
Okay.
The other is called radiometric dating. That's what geologists do when they study rocks and such, and that depends on the radioactive content. So radioactive rocks and minerals decay at a certain rate, and so they estimate, but they have to have a good estimate of how much it started with and how much it has now in order to make an estimate of the age. You could certainly question how do they know how much it started with?
Right.
Were they there billions of years ago and said, okay, it's at 80% to 20% now, parent to daughter ratio, and now in our modern time it's 20 to 50-50. I mean, how would you know in the first place? So they have different methods they think give them good confidence of the ages of those rocks. But once again, with the older, the more distant something is from us in time, the more uncertainties there are in that area.
All right.
And so the radiometric dating requires radioactive things. So if something's not radioactive, you can't date it.
Okay.
I'm actually, I mean, I'm not joking when I say I'm radioactive, because you're radioactive. Our body
we are.
is producing energy. Oh, absolutely, producing energy.
We are, yeah.
It's very, very low levels, but it's there.
And you can, I was taught that you can walk on the grass barefooted, and it really re-electrifies your body in a way that
I've heard that one I don't think I believe, but I haven't really studied it, but I don't know if I believe that or not. But I don't know. I never really studied it, but when I first heard about it, I thought about it and I thought, I'm not sure that something as big as the Earth, and whether I have 1/4 inch of shoes on or not makes a difference as far as how much electricity is moving back and forth. I know people who swear by it, but I haven't looked into it deeply, but I was suspicious of it.
Well, it kind of, if you look at the human anatomy and the what's in our heart, we got two little sparks there.
Yeah. No, actually, anatomy is not my strongest area, so I'll say
Okay.
I'll tell you, Dr. Lewis, I'll take your word on
it. Don't hold me to it, though.
Okay, all right. And by the way, since we finish this talk, I'm sending you all a written exam on today's talk, so you have to get at least 80%. That's what happens when the professor comes in.
Yeah.
Okay. Any more questions or anything before Jody goes to sleep?
He's
probably been sleeping.
He's out
Wake
of
up, Jody.
Is that a screensaver he's got up? Is he gone now?
We lost him. I think his connection dropped.
That's why he was staring so much. I thought he didn't blink for a really long time. All right, Scott. Well, thanks for having me on. I do appreciate it. I did have fun. This is my third show this week. I did ABNSAT the last 2 days, Aramaic Broadcast Network's Trinity channel. It's not the Trinity channel, but their Trinity channel. I talked about was Muhammad a prophet of the Bible, biblical prophet, on Tuesday, and then last night I did discussion on with some other people on both days with several people. But anyway, yesterday was on, does science prove or disprove Christianity? So been a busy
Yeah.
week.
That's great. The Trinity Channel with Sam Shamoon and David Wood.
Yeah,
I used to watch all that stuff. We know
absolutely.
about them. Yeah, and I met the owners of ABN Sat at the conference one year.
Oh yeah,
Nice people.
yeah. They're friends of mine, and David Wood. I sat in the studio next to him for a week, and after about 4 days, I said to I forget the owner's name, but I said I don't think I like that guy. He said, well, he's a psychopath. I said, no, he's a little bit of a jerk, but he's not a psychopath. He goes, no, you got to go to YouTube and watch the video. He is a psychopath.
Yeah. Well,
All right,
yeah,
take care, guys.
we really appreciated having you, Don. I'm selecting my hand clap emoji because you can't really applaud on Zoom, but we do appreciate you coming out, and we hope to see you again in a future episode. That's it, folks. Thank you. Good night, and God bless you all.